So welcome to EPIT Labs, and today we came with a new product, and this is about humanoid robotic arm. So in this product we can open this device. So you can see an 3D printed robotic arm that is automated with servo motors we have integrated, and this robotic arm will be controlled using our hand gestures by using some electronic circuitry. And before going to hardware components, we'll see the working of this device, and after that we'll see what are the components we have used and what the purpose of this device we'll see clearly. And I will just power on the device. So here we can see an hand gloves I have here, and this hand glove is connected with some flex sensors to get the hand gestures data, and according to my hand gestures the data will be transmitted wirelessly to the NRF. And this is the here we can see one box is there. There's a receiver circuitry, and this box indicates the transmitter circuitry with the NRF. And according to my hand gestures, we can see the hand is changing the gestures. So if I put like this, so like this we can control, and this robotic arm can be implemented where we want where we want to deal with chemicals, like in laboratories or else any machinery, any risky machinery. In that case we can use this robotic arm, and we'll see how it is operating. So inside we have inserted servo motors. We can open the hand here. So here we can see some servo motors are connected to these fingers to operate some thread, and according to my hand gesture the servo motors will align. So on remaining circuitry like microcontroller, we have used STM32, and we have used NRF for wireless data transfer. So here we can see the circuit diagrams for the robotic arm, schematic 1 and schematic 2. So first one is a robotic arm transmitter, and this one is a receiver side circuit. And in the both circuits have used microcontroller as a STM32 board, and I have used some servo motors and flex sensors. We'll go one by one. And this is the transmitter side. We'll see first transmission, we'll go to the receiver end. So here we can see STM32 board is connected with some flex sensor. So flex sensor will give the data of how much the finger has bent. It will give an analog data value to the STM32 board, and based on that data, we'll process the data and we'll send it to receiver side using this NRF board. So here you can see NRF 2L01 board we have used, and which is like a radio frequency module. And using SP communication, we have processed the data. We have send the data using this STM32 board. And remaining here you can see we have provided 5V supply using some adapters. And so this is about the transmitter end, and we will see the receiver end as well. So here receiver end, and after sending the data from the transmitter side using NRF, so another NRF we have to connect to our microcontroller to receive the same data. So that NRF will work as a transceiver, means it can send the data and it can receive the data based on the program uploaded to the microcontroller. So here also using STM32 board and NRF board to receive the send data from the transmitter side. And after receiving the data, we have to control the servo motors based on the data received. So the data mapped from the flex sensors transmitted to this receiver end, and after getting the data based on the values, we can control the servo motor. So for that we have used MG995 servo motors, and we have connected it to our STM32 board to the PWM pins, and we have used 5V 10 amps SMPS power supply here, and this is about So for more tech videos, subscribe to EPIT Labs Private Limited, and share our videos, like our videos. Thank you.